Hello,
Hi,
how are you doing?
I'm doing well, thank you. You?
Mm, I'm doing very good. All right. So I saw your notes. You wanted a ML engineer, ML system design kind of interview, right?
Yes, I haven't done this before at IK, so I don't
Mhm.
know what the format is like.
Okay, awesome. Very good. So let's go into a regular. See, the way ML system design or ML design interviews are is I'll take you to the structure. If you don't know the structure, I'll at least take you through the structure and then I'll guide you on that as well.
Okay.
Okay. So I'll first give you a problem statement. Um, so the effective thing is you have to design a search relevance system for a search engine. Okay, so that's the main problem statement. Design a search relevance system for a search engine. Oh, by the way, do you want to share a whiteboard or a Google Doc, whatever? You can just share your screen and whatever you're typing, I'll be able to see. I will not
Oh,
write anything.
okay, sure. I'll share my screen.
Okay, so the problem statement, like we said, is design a search relevance system for a search engine.
Okay. Oh, hold on, it's still coming up. Okay. Design a search.
Relevance system for a search engine.
For a search engine. Right.
Yeah.
Interesting. Okay. Um,
Okay. So, I mean, the other way to say it is design a search relevance system to display results on a search engine result page. So, effectively, what you have to do is this is like a general purpose search engine. This is not a product search engine. This is a general purpose Google like search engine, right?
mhm,
And
yeah.
the biggest thing is you are already logged in. So, this is a logged in user scenario. So, this search engine provides you ability to log in, right?
Okay. We are already logged in, so we're not creating profiles or anything like that.
Yeah. And that's it. So, what other questions do you want to ask me?
Okay, so this is a one sentence question. So
Mhm.
I would need some a lot more information to be able to understand what should work here.
Absolutely.
Yeah. So design a search relevance system to display results on a search engine. So what what size of um what's the size of this engine? Like, does it contain
Mhm.
documents or does it crawl some certain resources together?
Yeah.
Um,
So,
external
yes, absolutely.
information.
So it is just like Google. So it is going to crawl over the world, and we can assume maybe a 1 billion, documents that it has to index,
Okay.
and you can assume about 10,000 queries per second if you really want to know how many times will this be asked. So it's 10K queries per second
Okay.
to the search relevance, whatever.
10,000 queries per second. So, and this is okay because it's Google sized engine. So I assume it's a global.
Yeah,
It's a global. Okay.
global.
It's a global engine. Okay. So if it was like a full design of the whole system, I'll drill more into this information. But because what I'm expected to find is to get the most relevant information when a user enters a query, right?
Mhm.
Okay,
User
so
can enter a regular text query,
okay,
and they should be able to get results based on the text query.
okay, okay. So I think for user, expectations. Users should. So let's call it that information. Enter a query and get results displayed. Okay, so with this, another question that I have here is, I believe for us to be able to display information that won't be overwhelming for the user, I would like to know how many queries that you would want this, like a screen, like a desktop or a mobile, to display when we get the relevance. Like in a screen like this,
Mhm.
system should be able to display about 10 to 15 relevant results.
Yeah.
So is that a good number that you're looking
Yeah,
for? Okay.
that's a good number.
Okay, so the reason why I think this is important is because we don't want 100 of them to appear on the screen, and it will affect the user interface. Okay, so with this info, the user should also be able to get their results pretty quickly. They don't have to wait so much. So I believe once user enters their query, results are displayed within, because there will be some computation at the background to be able to get the most relevant ones. So 200 milliseconds, is a good number. Is it a good number?
Yeah, that's
Okay,
a good number.
200, the time to display, so that the user doesn't have to wait for too long. But then this will require us to have, let's say, a user who has logged in. If that user has searched that query before, it would have been cached, so that should be faster. But if it's the first time searching it, it will take longer. So for us to be able to have such queries return faster, that means we'll have to work on the throughput. So that's something to consider during the design. So the next would be, okay, number of relevant results to display, time to display, and that's about the user. What else? Does this engine, does this search system have to recommend words? When you start typing on the Google search box, you have some words suggestion. Does it have to have that?
No, not required.
Okay. All right. No, not required. Okay. So for this, system, we'll just only concentrate on the English language. Won't have to delve into other languages, but I believe it should be able to scale properly. So I'm thinking of because this is a global engine. I would have and the system
Yeah.
calls.
So I think don't worry about the crawling, whether it's global or local. That
Okay.
we'll not worry about in the problem right now.
All right. All right.
Okay.
Okay.
Um,
So,
I think the next thing you should focus on is the metrics.
yeah.
So what are the metrics, both online and offline metrics? So
Um,
how would you define success of your model?
yeah. So for the online metrics, what I will, once the system is in use, the parameters to look out for to determine if the model is performing properly is uh, a user um, clicked and read and spent. Okay, if user clicked on the first displayed page. So what I mean here is if we display the first 10 to 15 results, if the user is able to click one of the results in the first page, and that means that's a sign of relevance. But then if the user browsed through, they could have clicked the page, but then left the page as quickly as possible. So that would be a second time spent on a result. I would call it on a page, on a displayed page. So this is if a user spends, let's say they click on a link and they opened it, they browse through for about 3 to 4 seconds and moved, maybe click back and started looking for the next one, which means that wasn't relevant enough for what they were searching. So maybe they go to the next and or maybe move to the next page two, and they couldn't find what they wanted in page one, which I'm
Mhm.
tracking that by the time spent. Maybe in page two they were able to find a link that they spent a significant amount of time to read, which means
Mhm.
they could have it could have piqued their interest, or it could have given them what they wanted. So uh the if user clicked on the result on first page, on time spent, and that's for my online metrics.
Mhm.
Then for offline metrics, if I think of another metric for the online, I will come back to this. So
Mhm.
for offline, for my model, I would have to check. Okay, so no, for online, I think I'll be tracking so I'll be tracking the accuracy accuracy of the model, model accuracy. Yeah, model accuracy. Because this is search relevance. So this um,
Mhm.
model accuracy, I'm thinking of the true the um display time, or like a time to time what I'm trying to say here is like the time it took the query to display, like this display time. So for model accuracy, this would be looking into how the model is performing, the queries or the search results that are displayed. How accurate is it related to the keywords? So for example, if someone was searching for um, best place to buy computers or best shops for computers, and then in the display,
Oh,
did we?
so let's assume that's you already have a system which makes sure that you get the right results, because here the
Mhm,
focus is primarily on relevance, um,
mhm.
not on the whether the results are relevant to the text that has been given. Because
Okay.
right, so accuracy, how will you measure the accuracy? Like you said, like do you have any any guidance on what metrics that look like?
So the accuracy, so let me see. Let me think of this a little bit. So the accuracy, the model accuracy depends on, um, okay, so you said that we have a system in place that checks that whatever that is displayed is the correct document, right? But
Yeah,
then,
we only care about accuracy in terms of relevance for the
accuracy.
user.
Okay, accuracy in terms of relevance. So it would be to check the accuracy would be if the time that the user is spending on the page decrease it, like if the first page is displayed and then the user spends keep getting to more deeper pages before um they spend more meaningful time on a result, that means the model is not performing well or is not serving the right document that is relevant to the user.
Yeah. So think
So,
about, let's say in the past when you were training your model
mhm,
and you had an offline training.
mhm.
Um, how did you know your offline training led to a good model?
I so it would be in the testing. So while it's being trained, you're testing it with data that it hasn't seen before. So if it performs well on that, like the doc the trained model, if okay, so let me think of this again. So your question is, when I did offline training, how did I evaluate the that it's getting the right or relevant result, right?
Yeah, I mean, what do you do in offline? Like, let's say you have a model and you do offline training, and then you have the choice of whether you can take it to online or not. Like, sometimes you might say, "Oh, this is bad." Like, what makes you feel a model is bad? Because I'm sure you will use some metrics, right? Like, I'm looking for what kind of metric do you look for?
Oh, okay, I see. So it would be what the metrics to look for would be the how precise the results are, precision,
Hmm.
recall.
Hmm.
So it will be how precise it is at the displayed result. So if I'm getting like a lower recall, a very minimal recall, so that means my model is okay to go online.
Hmm.
Does that answer your question?
Yeah. Okay. So now let's move to maybe, can you draw an architectural high level diagram of how a search generally looks like?
Okay. So I think this was what I was explaining with this. I think it's the right words to use that I was thinking of here. The click through rate when they click on the
Yeah,
document.
yeah. Click through rate is perfect. CTR
Yeah.
is there.
Okay, so a
I think
high level.
CTR likely would be your online metric because that's where you see
Sorry,
offline.
can you say that again?
Your click-through rate is an online metric.
Oh yeah. That's right. Yeah, that's when the user is.
Yeah, which is effectively what you said. If the user clicked on the first page display, technically that's your click-through rate.
Yeah, that's right. Yeah. Thank you. So,
Mhm.
high level architecture.
Yeah,
Okay, so to draw a. Okay, so with docs,
yeah.
where.
You can just say insert,
Oh, okay.
and then you can say image. No, drawing. Yes, drawing,
Drawing.
and then you can say new.
Yeah.
So,
Yeah,
and
let's try that.
if you have never drawn, then maybe you can just type it. Like you can just type how the flow looks like from the query.
Okay, I can try that. I'll try.
Yeah.
Okay. So, to draw a just like a top level design of it. So the first would be the query,
Hmm.
where the user will put in their query. It's the search box, and so from there, I will my system should be able to. It takes the query and it retrieves since there's already a system that would make sure that the queries are correct. It will go through the documents, or it will go through the documents and retrieve the candidates. So these candidates might not be exactly correct. So it's with these candidates that I'm going
Yeah,
to.
I think you'll have to draw all that. Like, let's
Okay.
say this is the query which the searcher. So you
Okay.
start with the searcher, like who is the person who is searching. The searcher sends a query to
Yeah.
some query service. Now it's up to you how you want to split that out at a high level. You don't have to know the internals of how the index is created. Assume
Okay.
that the index is already there.
Okay.
Um, some of them could be black boxes, but you'll have to see where does the ranking system fit in your whole search flow.
Okay. So this is the user, and the user enters the query. Let's see. Enters the query. So then I will reach the keywords or the text that the user entered will um, go through the documents, like billions or millions of documents, and retrieve potential results, potential candidates
Does
that
it
will
go
go
to
through
the
the
documents?
filtering. Sorry?
Does it go to the documents? Like where are the documents stored?
Okay, so the documents will be okay. So I can I assume that there is a document indexed document pipeline somewhere? Can
Yeah.
I
So
assume that?
so I'm assuming that you want documents that are already indexed, right?
Yeah, a document that I already indexed because that's a whole totally. Can I assume that, or should I build it out?
No, you can assume, but you just have to explain what does the index mean here. Like,
Okay. Um.
so I'm assuming that there'll be some other process which creates the index. That's fine. But how do you like the index to look like?
Okay, so the index would be based on certain keywords.
Hmm.
So certain keywords that okay, so I could say estimated keywords that could be most often searched. So
Mhm.
it should be indexed in that way, maybe based on topics. Topics being it could be politics, education, science, in that regards, like in different categories, so that if a keyword is searched and it is relevant to that topic or a group of topics,
Yeah.
so that document indexing will be based on topic in certain topics. So when this candidate retrieval part of the process goes into that pipeline, it checks if it belongs to a certain topic.
Yeah. Perfect. Okay.
Okay. All right. So I think yeah, you asked where the document indexing is, so I'll just keep it by
Yeah,
this.
that's fine. That is so. So you have somewhere document index. Okay.
Yeah,
Yeah.
index.
Perfect.
Okay. And so my candidate is looking in. Oh, let me use the other one. This should work. Yep. Yeah, this should work. And or I should have picked the one that has an arrow, but my intention was this way. So the next would be to so once my candidate retrieval system looks into the indexer, then so for example, if it could pull about a 10,000 documents relevant to that, then all of those candidates can be scored based on how closely related they are to the topic.
Hmm.
So I'll say document scoring or article scoring. So let's see, articles. We'll use this again. So now it's looking some way. I was thinking that the boxes will stay, but that's okay. Uh, so this is my document scoring. Yeah, sorry, it doesn't look all right. I'll just use a line. It's not perfect, but I wanted to point correctly. Okay, so that's my document scoring system. Then what this would do would be, let's say I gather about 10,000 potential candidates. Then those documents will be scored based on how closely related they are to the topic. Then with that scoring, then the system will select the scores, let's say uh, 10,000, then a group of 100 of each of those documents. The topmost ones that have higher score will be filtered out. And so this is in a bid to reduce just keep filtering to get the highest quality result. So I would say we'll move on to the next stage. We'll be filtering the documents that are stored.
Hmm.
Yeah, so this will be filtering. This will be filtering. Okay, so after filtering, the next would be just like scoring the document. The next would be to also score the filtered one, or to rank it based on how closely related it is to the topic at hand. So I'll be ranking the filtered document. So the that's the next page. This is interesting to draw with. Right, so when after so this is like a trickle down process where we could have large amount as we go through the process of this pipeline. The number of candidates or number of ranked results will start keep dropping, and then after ranking this, we will get another set of ranked documents. So this will be around this part. We'll have about we should be having around the 10 to 15 queries that we'll plan to display.
Mhm.
So that's so once we get to this point, that's when the algorithms or the features, let's say the features or parameters that will be used to um, that'll be used to rank the remaining documents will be implemented, because we don't want to run our algorithm or the ranking system in we could do that, but that would take enormous amounts of time. So this is like just reducing the time that it would take to do heavy calculation. So from this point, I could get the parameters using embeddings. Yeah, could be used to gather the parameters or the features that will be used for ranking. Does that make sense?
Mhm. Mhm.
Okay. Okay, so this would be okay. So that's what this part will do. I'll just leave it that way. So at this point, um, while the features are being generated, because if what the pattern that is used for ranking these documents at this point, I would like to um, store them for multiple computations as time goes on, because the data will be trained as often as possible, because at the first time when this is created, it might not generate a good result. So I would be able to collect these parameters for continuous training. So from this part, we could get the data that we need for training, for future training, or for future optimization of the model. So I will say data generation, just because I'm doing feature extraction here. So so that will be for training. Right. So at this point, I think from here, after collecting this rank document, I should be able to return this to the user. Right. So I think should be able to return this to the user. Use this.
Okay, that's good.
Yeah.
So let's then go into documents and collection.
Yeah, so I could store my training data here.
So what are the kind of features that you will look for?
Okay, so the kind of features to look for would be
Yeah, you can close this. I think we got this. So maybe you can start typing.
okay.
So you can say save and close on the top. Yeah, that will show there.
Oh,
Okay,
it
so
actually came up here. I
yeah,
didn't. Oh, okay.
so you can edit it also just by double clicking it. It'll open that again.
Okay.
Okay, so you can press enter. Yeah. So what are the features? Now let's go into feature engineering.
Okay.
So what kind of features do you want to use for your model?
Okay. So the features that are used for my model will be first I'll have to have a I'll have to collect like an identifier for each request. Requests identification or request ID. Okay, so that's the that's one of the features. Well, just to start with.
Mm-hmm.
Let me give this a little thought. Um, hmm. Okay, so I'll collect the line of query, like query length, because collecting this or length of query or number of words. So that this to me is important because there are what is called long tail search queries or short two words queries, three words queries, and most times when users are searching on Google, there are some of the when these keywords are typed in, the suggestions that are coming while you're typing, it's usually almost always around two keywords, three, four, five, and that would help with helping the user to select keywords or searches that are popular or closely related to what they are searching. which could also help with user experience. I'm not sure if it's related. I think it is related. Should be related to search relevance because if a user is searching for best place to buy pizza and that's a popular um, query, then that will help the user to click on that. And then because it's a popular one, it would have been cached or it would have been optimized in a way that the result will be displayed to the user as soon as possible.
Okay. So we have about 15 minutes. So let's spend the maybe in the next 2-3 minutes just talk about how will your model architecture look like?
Okay. So my model architecture. So I will have information retrieval. So that's like an extension of the high level architecture. Is that what you're asking?
Yeah. Like, what kind of model would you use?
Okay, so the model that I would use would be a model that will they'll use what's that? I'm trying to a model that will use
Or what
okay,
machine learning algorithms would you use? Rather, that's because by model architecture, I mean what machine learning algorithm would you use? What modeling paradigm would you use?
okay. Yeah, so I'll make use of a a model that will leverage um, a tokenized. Sorry, my brain is super. This night is so late. Uh, I'm struggling to remember things that I know. So a tokenized indexing. Indexing. So yeah, I don't have that. So yeah, I'm trying to remember this. So that's so embarrassing. Okay, so why I'm saying this is because I would use a model that will treat the text data or the vocabulary and uh, represents the data in such a way that it could assign unique IDs to each word, and in that way, it will assign a unique ID to each word. That way, it helps with working closely with the document indexer, because if the words, like the words in the key in the queries, are unique enough, it will be able to be classified based on the topic. So that's there are a few models that could be used for such design. That would be, we could use a bird, and that's one of the most recent ones. Then we could also use um, information retrieval system. Sorry, I've gone blank. That's so
Hmm.
crazy.
Okay. So I think we are pretty much done. Yeah, about
Okay.
10 minutes. So what do you think? Did you get the structure?
No, I didn't. I think it's a bad idea to interview by 10 p.m.
Yeah. So I think the first thing, obviously, I'll just give you the structure. Talk about the problem statement, go deeper into it. Like, for example, the questions that you asked, it could be around scale, it could be around even the whole problem. Like, for example, the question would ask will be just a search relevance system for a search engine.
Hmm.
That's the only question you will get. And then after that, you have to ask more questions like, is it a logged in user? Is it a general purpose search? So you have to, all of that. The first line is what you'll get. That's it. And you have to deep dive into whether the user is logged in, where do you get data. So that is the first thing. The second is metrics, obviously, offline, online metrics. Um, Even offline, there are things like cumulative gain or normalized entropy. I think you need to talk about all that. I
Okay.
didn't hear you speak about any metric. You were just generally saying I'll see accuracy and all, but that is no meaning, right? Accuracy,
Yeah,
anybody can
I
say.
think
Even a
I
non-ML engineer knows that they need to see the accuracy. So, so that is one thing. Because if you have actually worked regularly, you would know what offline metrics you would look for. It should be exactly the name, or at least the name of online offline metrics that you care about in your
mhm.
past. It doesn't have to be for this particular problem. So then talk about in your scenario what were the metrics that you look for, and that is fine. Because we don't expect everybody to know all scenarios, right? Like some people might be good in relevance. You might not know how a self-driving car works, right? That's okay.
Yeah.
How a vision system works, maybe that's fine as long as you have one ML background of something, right? Then you talk about the architecture, which is the drawing that you have to do from end to end. So I think you did the drawing. That is reasonable. I think it's more like black boxes that you are drawing where the search is happening. How do you get the documents at a very high level, and where is the ranker fitting in? At the end of the day, you know need to know where the ranker fits in and how do you return the results back to the search page. Um, then, in some cases, you might go more deeper into how the retrieval itself works, like how the inverted index works and all, but that is not necessary for this problem. So, given the time,
Okay.
you don't need to get into it unless the interviewer asks for it. Then I think feature engineering also, yours was very, very light. I think you have to go more deeper into what are the different features that you look for. For example, you have to look for the search features, you have to look for the query features rather.
Mhm.
You have to look for the searcher as well. You need to know about the documents, you need to know about the context. So even if you don't go into each, you have to go at a high level what categories. Like for example, if you are looking at a user specific feature,
Mhm.
you might want to know what is the user's age or user's location, or um, all those things you'll have to talk about.
Okay.
Um, so, so effectively, you have to talk about actual query features, right? Um, so, right. So you don't have to go into tell me exactly, like for example, searcher specific feature, right?
Okay.
Um, you know, the searcher specific feature could include, maybe what did the user, or what is the age of the user, what is the gender of the user, what are the past interests of the user, what were the previous queries that the user did, or
Okay.
something like that. And then queries specific features could be more around uh, maybe the, like I think things like, um, I think anything. where you want to know more about the query. Like, for example, if somebody says, I want to get some good food, then you'll have to say maybe connect it to restaurants or something like that, like all those things.
Okay, based
Uh,
on maybe location. Okay, okay, I
yeah,
get what
no
you mean.
location. So from a high level, there are three, four things. Like I said, searcher, query. Query would only care about uh, general query, but you're right. I think local could also come in from the query itself, right? The query intent could be that if somebody's saying I'm hungry, then the
Hmm.
restaurants should be local,
Yeah.
right? Then you can also have context. For example, if the um, so let's say I search for a restaurant at midnight, then you should only show me all the restaurants that are open at midnight, right?
Hmm.
So it could be context as well. It could be I'm searching for I'm hungry, I say, and then and I'm in, let's say, San Francisco, then it should give me results from San Francisco. So those kind of things are more relevant at that point of time, right? So
Okay.
so you have to go into features which you did not get into a lot. Then I think generally you should talk about how do you generate the training data.
Hmm.
A lot of times that's an important aspect of your whole end-to-end model exploration. How do you generate the training data? And um, right, so either you can expect some users to rate the results because you don't know. So you
Yeah.
can do either offline or you can do online
Okay.
based on user engagement.
I could use batch processing.
Yeah, you can do that.
Okay.
Right?
Oh, I didn't know I could talk about that. I think I need to refresh my knowledge about all of the different steps.
Yeah, and then you have to talk about model architecture. I think you did talk about model architecture at all, which is, what will you do? Like some people say I'll use logistic regression, um, and then I can do multi-stage ranking, like because you have so many models, or rather so many documents that you have to, um, which might actually classify from your search results.
Hmm.
Like you can say, um, um, like for any document, let's say the index, for any query, the index might give you back many documents,
Hmm.
and you might have to then do a multi-stage ranking kind of thing where um, you first stage is mostly very fast but not very accurate, and second stage is more accurate and slow, right?
Okay.
So that's the general process for any ranking problems, multi-stage ranking. I think you should read about it in general, how
Yeah.
multi ranking works. So you have to talk about exact, like some people for certain problems you might say I'll use regular regression kind of thing, or normal regression, right? So uh, sometimes you'll use logistic regression. So you don't have to go into deep neural nets and all, but think about regular uh, machine learning algorithms, standard algorithms, and see which one you apply at which point. And and then you might also want to at the end filter some results as well. So talk about that um, as well. Like at the end of the day, your ranking results might come, but you might not return everything. So you might want to also do some filtering. And so that's it. Those are the kind of things you have to talk about:
Okay.
metric, architecture. Then you talk about feature engineering. Then you talk about training data, and then you talk about your model. And
Okay.
primary, at least, those are the main topics.
Awesome.
Yes.
Thank you so much. At least I've got
All right.
a feel of where to improve. Yeah, it's helpful. Thank you for the feedback.
Awesome. Very good. Best of luck.
Thank you.
Good talking to you.
Okay. Bye. Good night.